Hey guys, this is Algebra 2, the Big Ideas Math Textbook, Chapter 6, Section 5, and what we're doing today is properties of logarithms, and properties of logarithms to, it says solve problems, but really what we're doing is kind of more evaluating. So you can think of it as problem solving, but we are evaluating today. So in your foldable on the product property page, product property of logs, that's where you're at. You have this property that says any log base b of u times v is equal to the log base b of u plus the log base b of v. Now, what I want to do for you is just show you, you already knew this. You really, truly did. Because what is multiplication, right? A to the m times a to the n. What really is multiplication? Multiplication is addition. And we've been saying multiplication is addition for so long now that you should not be surprised that multiplication is actually addition. Okay. Now, we're going to do some variable problems in here, but first let's cut to the chase with our actual values, our numbers. Basically what is happening is we are supposed to approximate log base 5 of 21. Now we could put this in our calculator, of course we could, and our calculator would give us the answer and that would be that, and like we're done. But there is a way to do this without the calculator. And it is breaking this up, saying, hey, wait a second. Log base 5 of 21 is really log base 5 of 3 times 7. And log base 5 of 3 times 7 is really log base 5 of 3 plus log base 5 of 7, because multiplication is addition. And so now that we figured out what way to break this up, we can take the values they gave us, which is 0.683 plus 1.209, and we can just straight up do this. Now we can do it with a calculator or without a calculator, it doesn't matter, but I get 1.892. Okay, so one more time what we did. We saw in the problem that we were supposed to use log base 5 of 3 and log base 5 of 7. So when I came down here and saw 21, I said to myself, hey, 21 is really 3 times 7. And using that product property of logs, product meaning multiply, if it's 3 times 7, I'm allowed to break up the logs, make 2 logs instead of 1, and take those logs and add them instead. And so when I add them, what I end up getting is the 2 decimal approximations summed up to 1.892. Okay, here on example 2, it's the same idea. They tell us that log base 9 of 5 is a value and log base 9 of 11 is a value, and they give us log base 9 of 55. And so we're like, what's 55 made of? Well, if we have to use a 5 and 11, then it must be 5 times 11. And we are allowed to split up the log base 9 of 5 times 11, and we just say it's log base 9 of 5 plus log base 9 of 11. But what does that really mean? Well, what it really means is that all we have to do is take the 732.732 and add it to the 1.091. And we can do this in our head or we can use the calculator to do it. But we get 1.823. All right, these are our numerical examples, and now let's do some variable examples. What we have basically is the word expand. And it's the same thing here. We're going to use the product property because right now it's log base 5 of 2x. The 2 and the x are multiplying. And so we need to break them up. The act of breaking them up is addition. And look at this. I don't know why it makes that box. Okay, look at this. This is log base 5 of 2 plus log base 5 of x. It got bigger. It expanded. That's right. Expand means get bigger, and so we took what used to only have one logarithm, and now it has two logarithms, but we are, in fact, done. Okay, now we can go backwards. The word condense means squeeze it all in tight, make it smaller, condense it up. So we are given an addition problem. And in our mind, we say, hey, addition is really multiplication. Okay, so we're going to multiply. That was silly that that happened. We're going to multiply. So this is just the log. Is there a base this time? No. So it's an invisible 10. So we have the log of 5x. We multiply them. We're done. Okay. We are now on the page quotient property. See that? We are up here at quotient property. It's another yellow page. And the quotient property says, hey, look, if there's a quotient, if there's division, what we really do is we subtract. Now go with me for just a minute. Remember when it was a to the m over a to the n? What did we do? Wait, you mean to tell me we subtracted? Division is subtraction. You already know this. We've already done this before. Division is subtraction. Okay, let's give it a try. They give us the log base 5 of 3 and the log base 5 of 7. But this time they're asking us to approximate log base 5 of 3/7. We say to ourselves, hey, that's division. So if it's division, I know it's going to be the log base 5 of 3 minus log base 5 of 7. Okay, that's our music, so I'm going to pause it. Great, okay, so I'm about to put the approximated values. That means it's really 0.683 minus 1.209. So I can do the subtraction by hand, or I can do it in my calculator, and I get 5.26. Okay, I hope you're realizing that, of course, you could put this in your calculator and get an answer. But I am taking the time to teach you how to do it this way. What does that mean? That means that you're going to be tested on how to do it this way. I know you can use a calculator. Anybody can use a calculator. But not everybody knows that what it really is subtraction. So just keep that in mind. There's a purpose for what we're doing. Okay, over here we have log base 9 of 5 and log base 9 of 11. They want us to approximate log base 9 of 5 divided by 11. So what that is log base 9 of 5 minus log base 9 of 11. Just like that. Okay, so plug in your values. You have 0.732 minus 1.091, and that is negative 0.359. All right, now we're going to do it with some variables. When it's done with variables, we call it expanding. You start with one log, and then you're going to have lots of logs. Here's how I like to do these problems. There's multiple ways, but just go with me on this. I say to myself, the 7 and the x are multiplying, and multiplying is addition. But the 7x and the y are dividing, and dividing is subtraction. So there are two ways of starting this problem, but I personally do this. I say, that division line is my subtraction, and I break it up. I say log base 2 of the whole numerator. See, I put the 7 and the x here, minus log base 2 of y. Now my next step would be saying, okay, I know that 7x breaks up, so log base 2 of 7 plus log base 2 of x minus log base 2 of y, and I break it up that way. The other way we can do this, and I do this way, is literally count them. A 7, an x, and a y. How many things do I have? I have 3. That is how many logs I have. Okay? I counted 7, x, and y. That was 3 things. That means there's going to be 3 logs. Now, go with what you know. 7 is in a numerator, which means that is positive. X is in a numerator, which means that is positive. So 7 was in the numerator, it's positive. X was in the numerator, it's positive. Y is in the denominator, which means this is negative. Numerators are positive, denominators are negative. Take a look right here. It's the same as our final answer. I don't care which way you do it, whatever's more comfortable with you guys, okay? Over here, condensing, that is when you see multiple logs, but you know at the end of the day, you're going to have one log base 5. Now, you look at this and you're like, whoa, it's subtraction. And what is subtraction? Subtraction is division. How do you know who's on top and who's on the bottom? Well, the positive logarithms are in the numerator, which means 8 is in the numerator. The negative logarithms are in the denominator, so that means 12 is in the denominator. And I actually can't type right now. There we go, 12. Now, you want to circle this and have it be your final answer, but I'm sorry, guys. This is log base 5 of, what is that really? 4 goes in there twice, 4 goes in there 3 times. All right, moving on. Now we have the power property. So we've turned the page again. Look, we're on the power property of logs. And the power property says, if you have log base b of u to the n power, see how that's to the n power? That actually just drops down in front and becomes n times the log base b of u. Okay, remember this example that we've already been doing for the past couple days? You have x squared raised to the 4th. What do? You multiply. So powers mean multiply. All right, you already knew that. Powers mean multiply. Okay, so you got this. You're ready for this. We have log base 5 of 7. Here's its approximation. They want us to approximate log base 5 of 49. Well, that's like saying log base 5 of 7 squared. What you do is you bring down the 2. So that's like saying 2 times the log base 5 of 7, or 2 times 1.209. Well, what is 2 times 1.209? It's just 2.418. Ta-da! Okay, let's try again. It's log base 9 of 5 is what they're giving us, and they say approximate log base 9 of 25. Well, that's like saying log base 9 of 5 squared. I must click something or something to make that happen. 5 squared. And so this is 2 times the log base 9 of 5. Well, 2 times 0.732. Let me think about that. 1.464. All right. Now let's do some. We've got condensing. Condensing means you start with a bunch of stuff and you end up with 1 log. Now I say to myself, I see positive, I see negative. Negative means I'm going to have a division line. The other thing I see right here is that there's a 2 in front of this log, which means it is coming up here. It's coming up. So this 6 is positive. See that? So it's on the top. This 2 squared, remember this is 2 squared now because that 2 came up. So times 2 squared. And this log is negative, which means it's down in the denominator. So I really have a 6 times a 4 over a 3. 3 goes into 6 twice. I really have 8. So what I have is log of 8. It has an invisible base, so we don't need to say that part. Okay, trying again. Look at the original problem. It says condense. Right off the bat, I've got a 2 in front of my log. That means that 2 is going to become an exponent on the 7. I have a 5 in front of this log. That means that 5 is becoming an exponent on the x. I see subtraction. So I know this is going to be log base 3 of division. The negative logs go on the bottom, so x to the 5th is on the bottom. And the positive logs go on the top, so 7 squared is on the top. Clean that up, and that's log base 3 of 49 over x to the 5th. So remember, when you're condensing, at the end, you should only have 1 log. You start with a bunch of logs, you end with only 1. Okay, it says expand. It's log base 5 of 2x to the 6th. Okay, here's how we're going to do this. Either method works. We can just break them up one at a time. We can count them, whatever you want. But there is no division. So since there's no division, there's not going to be any subtraction. What I see is a 2 and an x to the 6th. So what I'm going to have is log base 5 of 2 plus log base 5 of x to the 6th. And then I have to say to myself, whoa, hold up. That 6 is coming down. So this is log base 5 of 2 plus 6 log base 5 of x. Some of you, I'm sure, can skip that step right here and just know to bring the 6 down. And if you can, go for it. All right, here we go. Look at 6x cubed y z. It's all in a row. They're all products. So are we going to have any division? No. How many logs are we going to have? 1, 2, 3, 4. And what's special about this log? It's going to have a 3 in front of it. Okay, let's do it. This is log base 4 of 6 plus sign 3 log base 4 of x plus sign log base 4 of y plus sign log base 4 of z. How did I know they were all plus signs? Because there is no division, and multiply means add. Great, we're done. I hope you're having a really wonderful day.